Hello, my name is Derek, and today I'm going to be teaching you about using the hole wizard in SolidFace. So as you can see, I have a cube that I've created in front of me. So I drew a square, and then I extruded it up the same distance as the sides, and I created a cube. So now I'm in my part window, and I'm outside of my sketch plane, so I have some of the default commands available to me. Now if I look to the top left of my screen, I go from left to right. I have collab workspace, plane, projection offset, extrude, revolve, loft, sweep, and hole. And hole is the hole wizard, and that's what we're going to be talking about today. So I'm going to go ahead and click hole, and that brings up our hole wizard. Alright, so as you can see, there are a couple different types of options that we have available to us. Different types of holes that we can make. Simple, counterbore, countersink, tapered, and fillet. So a simple hole. You give it a diameter value and a length value, and that's it. And we have a counterbore hole. So now you give it the diameter of your the actual counterbore itself, the length of the counterbore, and then you give it the diameter of the hole. Countersink, you give it the diameter of the countersink, the angle and the length of the countersink, and then the diameter of the hole. And for tapered, it looks a lot like countersink, but there's no hole diameter. And for a fillet, it's a lot like a countersink hole, except for instead of an angle and a length, they're giving it a radius. And this will create a fillet around the edge of your hole. Alright, so we'll go ahead and we'll get started with a simple hole. And I happen to know that I created a 1.5 by 1.5 cube, so I'll say 0.25 for my diameter, quarter-inch hole. And I'll give it a length of 0.5. Now I'll hit OK. Now it's telling me at the top left here to define face, surface, or plane. So I can define this face right here, and as you can see, it's not really letting me pick anything because I don't have any points or any lines sketched on top of that face that I could select. But one of the tools in my auto cursor on the bottom left that I can do is face center. So if I select face center and I scroll over this face, you'll see this yellow dot pop up, and that represents the center of this face, and therefore something I can select to select the center point of my hole. So I'll select that, and then as you can see, I have a small hole in the top of my part. Now something to take notice of here is that it looks, if we zoom in, you can see that there's a small center point there. Oh, okay. There's a small center point right there, and it looks like there's a radius at the bottom. Now, so the cool thing is that much like drills in real life, whenever you create a hole in real life with a drill, it will leave a small chamfer at the bottom to represent your drill point angle. A bunch of common ones are 118 degrees and 132 degrees for common drills. And SolidFace will replicate that. By default, it's 118 degree, being generally the more common of the two, although 132 degree drill point angles are starting to show up a lot more. So we have a normal hole. So I'm going to go ahead and sketch on this face, and I want to make an arc circle, and I'll drop the center point right there, and then for my radius I'll put 0.5. Alright, and I'll hit X and the green check. So now I have another entity to pick for my further holes. I'm going to go back to my hole, drag this over here. Instead of simple this time, we're going to go over counterbore. So counterbore has a diameter of the counterbore. So like if you're using a socket head cap screw or May variants of machine screw, you'll want a counterbore in order to be able to sink your fastener flush with the face of your part. So I'll go ahead and I'll say counterbore will be 0.375 and the hole will be 0.25 again. And I'll hit OK. Now it's asking me to define surface face plane, so I'll define that surface. And the end, so where this is going all the way through, so I have to rotate down here. I'll select that. Now I need a center point. So I define the circle because I can use this auto tool right down here with quadrant. If I come over, I can select one of the quadrants of the circle. So I'm going to select this one. I'll hit cancel. Now if you look at it, there's two holes there. See? The larger hole being the counter bore that we gave it, and the smaller hole being the 0.25 diameter hole that we created. And this counter bore is down to the depth that we specified. So I'm going to go ahead and put this back in the isometric view so you can see again. I'm going to open up the hole tool again so we can go through some of the other options. So we just did counter bore. So now we're going to go over Countersink. Now, Countersink generally has an angle of 90 degrees or 45 degrees, or actually usually 90 degrees, and as well as a starting diameter and any diameter. So we'll keep starting diameter and any diameter. We'll change this to 90 degrees, and for length, I only want to go down to we'll do 0.15 or 150 thousandths of an inch. And the second one will have another 0.25 hole. And I'll hit OK. Define surface face plane. Alright, cool. Center point. So I'm going to go back over here to my quadrant tool. I'm going to select this quadrant. Alright. So if we look in here, you see that there is a small chamfer around the edge of the hole representing the countersink that we created. Alright. We go back to isometric. So we've got 3 out of the 5 hole tools. I'm going to select the hole tool again. Now, as you can see, Solid Face will remember whichever option you had last in case you want to use that tool multiple times on multiple faces and you have to reselect it. So another thing real quick is like I was mentioning for the drill point angle at the bottom of these holes, if you come over to depth conditions, it says V-type / angle 118 degrees. And this is where I could change it to 132 degrees or even 90 degrees if I'm trying to replicate a spot drill or something like that with a more steeper drill point angle. Alright, so now we're going to go to tapered. As you can see, tapered doesn't have anything to do with the second depth because it's almost like a spot drilling operation or a ball detent for a spring load ball bearing, something like that. So I'll hit OK on all this. I'll leave it all the same. I'll define my surface face plane as this. And the center point, I'm going to go back to my quadrant tool. I'm going to select that. So, as you can see, I have a tapered hole that ends at a point. And if I rotate up, you can see it right down there. Alright, so I'm going to put us back in the isometric view. Alright, and we're going to go over the last hole type, and that's a fillet hole. So these are more specialized. This is something that you would use a special tool to create a fillet around the outside edge of your hole. But I'm going to say 0.15 radius. I'm going to give 0.05 or 50 thousandths. The diameter of it, we'll stick with 0.375. Diameter 2, we'll stick with 0.25. And I'll hit OK. Define my surface, so I'll select the same one. Go back down here to my quadrant tool, and I'll select this right there. Now, cancel out that. Now you can see that we have a nice fillet around the side of our hole there. Pretty cool. Alright, so I'm going to go to isometric, but now instead I'm going to go ahead and sketch on this front plane right here, and I am going to create a line. I'm going to select from my auto tool, center face, and then I will come down to the midpoint of right there. Alright, so I made that line so I'd have a nice center point right there on that face, if you can see it a little bit better like that. I'm going to go ahead and put this in the front view so you can see it. I have one more thing to show you on the hole tool. So I'm going to go back to a simple hole. For diameter, I'm going to say 0.25. And I can do something down here on the bottom left. It's cosmetic thread dimension. So if I say create thread, I have two different standards organizations I can choose, ANSI or ISO standard threads. So I'll go ahead and I'll pick ANSI, and then it comes up with standard type. Now I have different sizes of thread that I can pick. So I have a 0.25 diameter hole, so I'll say 1/4 by 20 UNC thread. 1/4 being 0.25. Alright. Thread diameter 0.25 inch, obviously. Diameter of the hole. All of this will update with my create thread parameter here. So I'm going to say through hole. I'll hit OK. Tells me to define a surface face plane. I'll find the end plane since I defined a through hole, and I'll select the back of my part like that. Okay. So now the center point. I'm going to come over here and I'm going to select endpoint of a line. I can also do center of a face to select the same thing here. Alright, I'll hit cancel. So one of the things that you need to notice about solid face is that it will not actually create that thread. But if you're to export this to a drawing, this hole will be annotated as a 1/4 by 20 hole. And that's something that's important if you want to make a part and then create a blueprint off of that part and send it to, like, say, a production floor or something. You can create this hole. It won't actually create the thread. That takes a fair bit of system resources and is kind of unnecessary in the modeling world. And then you will send it to the production floor and they'll be able to read your print and be like, okay, that calls for 1/4 by 20 hole, and then you get myself a 1/4 by 20 tap to create this hole with, so on and so forth. So that's the hole tool. I hope you learned something today. As always, thank you for watching, and don't forget to like, comment, and subscribe to our videos if you would like to stay in the know. Thank you.